In order to help explain the results of Young's double slit experiment, we need to first look at, say, the diffraction pattern of water and how it would behave if it were to encounter two slits, and say these are like barriers and there are slits in between. How would water react? Now, water, as these blue sort of lines, moves in a ripple in that wave pattern. So whenever water encounters a new slit, it starts a new diffraction pattern. So say, for example, this slit over here, which I'm about to show, this slit over here, we're going to let me just copy that, let's clone. I'll move that right somewhere around here, right? It starts off at this little slit over here. And what I'm going to do is I'm just going to change its color to make it red. Now, what about the other slit? So obviously we need a new diffraction pattern over there. So what I'll do is I'll just clone that, put that over there, something like that. Yeah, and I'll just change the color so we can see it somewhat differently. I'll change it to green. Okay, so this is how the diffraction patterns would emerge when it encounters new slits. What's interesting to note is, where do these diffraction patterns interfere? In other words, where is the constructive interference and where is the destructive interference? So anytime where the two meet, right, they're already these are the crests of the ripples. So when a crest meets another crest, obviously it's constructive interference. So wherever they meet, as we can see they meet here, this meets there, or this meets here, here, we'll probably meet there, here, here. What we observe is, if we were to, say, connect a line through all these points of constructive interference, oops, let me get a straight line there, okay, so we draw a straight line, it would go through these points right here, okay, or it would go through, say, these points right there, and it would go through these points right here. Now, the interference would be most, the greatest amount of interference would be the central line over here. And the further you move away, and obviously we'll probably have lines of interference maybe like here, we haven't really drawn them, or maybe somewhere like here, and so on and so forth. So the further you move away, as it dissipates more energy, the lines of intensity of interference will dissipate as you move away. And let's now say instead of treating this as a diffraction pattern of water, let's just do a simple thing and call it, let's say, the diffraction pattern of light. Right? Remember, when we put a screen at the end over here, right? What we noticed with Young's double slit experiment was that we observed, a number of lines. We observed the most intensity over here. Then there was another line over here, which was slightly less intense, and then slightly less intense, and then again here, slightly less intense here. We observed a number of lines instead of simply two regions, where we expected the particles to go through. We saw a number of them. So if light, the only way we can explain the number of bands that we saw on the screen, this is the, oh no, let me use a different color. This is the screen. This is the screen. The only way we can explain all these bands of light on the screen is if light was a wave. In our next video, we're going to explain the mathematics behind these diffraction patterns of light.